guys, in this video we're doing shell method. So I wrote down to start the basic thing. As you can see, it's pretty different from disk method. It is 2 pi, and then we're going to be doing the rectangle and the location of the rectangle and multiplying those together and taking the integral, and that's what's going to give us the volume. So let's start off, jump right in. We have the curve y equals x squared bounded by x equals 0 and y equals 4. So I drew the line y equals 4 and the axis is x equals 2. So I just drew the line x equals 2, and we know that that's going to be the axis of rotation because it was given to us. So this, we're going to draw our representative rectangle, which will be in between these two curves. So it's going to be like that. So basically, as you can see, the rectangle is going to be parallel to our axis of rotation, and that's why we're going to be doing the shell method rather than the disk method. So if you remember, like, for example, we would have a thing like this and like this. This is where we were rotating, and this would be our thing. This is disk method, right? Now it's like this. Like, for example, if we did it around the y and we had one like this, this is shell. So we're doing shell method. So what we're gonna do is kind of start setting it up like this. You have to find the intersection right here so that you know your lower bound is 0 but your upper bound. If you do the intersection, you'll find this point is 2, 4. Okay, so since the intersection is at 2, 4, we know that our upper bound is going to be at 2, which is perfect because then it's like right on the axis. So we're going to start, we can start kind of like trying to set it up, and then I'll explain as we go along. So 2 pi we know our bounds now are 2 and 0. And then the rectangle is going to be found by doing the upper minus the lower curve. So our upper curve is just 4, and then we're subtracting x squared. So this is going to represent the value of our rectangle. Sorry, I'm just trying to like organize it. So it's upper minus lower. So this is the value that we're going to plug in here. And then we're going to multiply by the location. So let me scoop this up. I'm going to try to explain location really fast. Let me draw some stuff. Okay, so there's going to be two situations: when the axis of rotation is to the right of the rectangle and when it's to the left of the rectangle. Okay, so if your rectangle is to the left of your axis, if the blue is the axis, you're going to do a minus x, and that's what you would multiply by. And if your rectangle is to the right of the axis, like here, you would do x minus a. So here's our axis, here's our rectangle, it's to the left. We're going to do a minus x, which means we're going to do 2 minus x. And that's what we would end up integrating. So we can get our calculators, and it would just be plugging it in as normal. Oh, hold on, I'm doing this real time, so 2 minus x, and then you do comma x, comma 0, comma 2. I got 40 pi over 3. So hopefully that's the answer and I didn't mess up. Boom. Okay, we're gonna do 1 or 2 more now. Okay, here's the next question. We have our two curves. The top one is 4x minus x squared, and the bottom one is x squared. We're going to be rotating it around the y-axis. So we're going to go ahead and draw a rectangle, and our rectangle is going to be parallel to the axis, which means we're going to use shell. I don't know if I said this earlier, but it's like, if it's parallel, use shell. You know, it's a little like remembering mnemonic thing. So we're going to go ahead and start plugging things in. So we have our 2 pi, and then we need to find our bounds. So we need to figure out what this is. For that, you just use your intersect key, or you could send these set these two curves equal to each other and figure out the zeros. But for the sake of time, it's 2, 4, which makes this 2. So our bounds are going to be 2 and 0. And then we're going to subtract the top curve from the bottom curve and multiply by the location. So top curve is for x minus x squared, and then we're going to subtract x squared, and then we're going to be multiplying by location. And again, the location is going to be x minus a, because it's to the rectangle is to the right of the axis, or the way I said it before was that the axis is to the left of the rectangle. So it's x minus a is 0, so it's just going to be multiplied by x. And then that's it. All you have to do is put it into your calculator. I already did it. I got 16 pi over 3. And yeah, that's about it.